Hi everybody, this is going to be another Chapter 7 video about factoring. Before we get started though, I've got two problems here that I want to talk about that are really going to help us with the type of factoring that we're doing today. So, two problems here. Okay, what two numbers multiply to 49 and also add to negative 14? Okay, so I want to show you this little organizer that we can use to help us figure this out, to organize our work nicely. Okay, we're going to make an X. We're going to put an M up here, an A down here. So M is for multiplication, A is for addition. We need two numbers that multiply to 49 and also add to negative 14. So think about this. If I have two numbers that multiply to make a positive, but add to make a negative, what does that tell us about those two numbers? Well, if I have two negative numbers will multiply to make a positive, but when we add them, it's still going to make a negative. So the two numbers we're looking for are both going to be negative here. So let's think of some ways that we can multiply to get 49. We can do 1 and 49. We can do 7 and 7. Okay, well, the 7s stick out here. If I do 7 times 7, that gives me 49, and we said both of them are going to be negative here, so negative 7 times negative 7 is positive 49 when we multiply, and when we do negative 7 plus negative 7, we get our negative 14. Okay, so these are the two numbers that satisfy that requirement. So I want you to pause the video and I want you to try the second one. All right, so for the second one here, we're going to use our organizer again with the X. So multiplication on top, addition on the bottom. We need two numbers that multiply to 24, and we need those same two numbers to add to 11. So multiply to a positive, add to a positive. Both of the numbers we're looking for are going to be positives. So let's think of all the ways that we can multiply to 24. We could do 1 times 24. We can do 2 times 12. We can do 3 times 8. We can do 4 times 6. Okay, well, which of those combinations of numbers would add to 11? It's going to be the 3 and the 8. So 3 and 8 multiply to 24, and they also add to 11. So we're going to be doing this same process today when we are finding, when we're figuring out how to factor trinomials. Now remember, trinomials have three terms, and specifically we're going to be looking at quadratic trinomials for the most part. So here's the general form of a quadratic trinomial. Okay, we have x squared plus bx, so b is just a number, plus c, which is just a constant. Okay, to factor a trinomial of that form, we need to find two numbers, two integers that multiply to c and add to b. So that's why we did those two warm-ups, because we're going to be doing the same kind of thinking when we're factoring. The other thing that you need to keep in mind is when we have trinomials, the factors are always going to be in the form x plus some number times x plus some other number. Okay, those two numbers that we're looking for are what we get when we're thinking what multiplies to this and adds to this. Okay, so here's what we're going to do. We're going to make our x again. And in the notes here, it says we need to find two numbers that multiply to c. Okay, this is my c value. So two numbers that multiply to 12 and add to b. Okay, 7 is my b value. So two numbers that multiply to 12 and add to 7. Okay, well, 12 we can do 1 times 12, 2 times 6, 3 times 4. The combination that also adds to 7 is 3 plus 4. So 3 and 4 are our special numbers here. These are the numbers that are going to go in here. So at this point, we have successfully factored this quadratic trinomial. Okay, and remember, we can always check our work by multiplying back together. And I want to show you why this method works, because anytime we have a quadratic trinomial, our x squared always comes from multiplying the x times the x together. That's why we always have an x at the beginning of both. And then we get a plus 4x plus 3x. So notice these middle terms add together to get 7, so that's why we were looking to add to get 7 here. And these last two numbers always multiply together to give us 12. Hence, we multiply to get the 12 here. So that process that we go through is just kind of the reverse of foiling. We're thinking about it backwards, kind of reverse engineering it. Okay? And you can see that when we do combine those middle terms, we get exactly what we started with, which was the point here. The two factors, the two things that multiply together to give us that polynomial are x plus 3 times x plus 4. And remember, the order of a multiplication doesn't matter. So if you got, I'll do it up here, if you got x plus 4 times x plus 3, that would be the same thing. Okay, the order that the factors go in does not matter. So let's look at some more here. Okay, these require good number sense. So again, we have a quadratic trinomial. We know the general structure is going to be this. We're going to have n at the beginning here plus some number, and we need to figure out what those numbers are. So we're going to use the x again. Okay, multiplication up top, addition on the bottom. Remember that we need to find two numbers that multiply to c and add to b. So c is 20, b is 9. So let's think of all the ways that we can multiply to 20. We can do 1 times 20. We can do 2 times 10. We could do 4 times 5. So the combination that adds to 9 is 4 and 5. So we're going to put a 4 here. We're going to put a 5 here. Or we could reverse the order. We could have n plus 5 and then n plus 4. And again, that is your answer. Those are the two factors that multiply together to give us n squared plus 9n plus 20. Okay, I want you to pause the video and try this one on your own. All right, so here I'm going to set up my factors again. Remember, h's will go in the very beginning of each. We need to find these missing numbers. So let's make our x. We need to multiply to c and add to b. Okay, so I'm going to list my combinations that multiply to 18. Okay, so those are all the ways that I can multiply to get 18. 3 and 6 are the only numbers that I can use to add to 9, though. So I get h plus 3 times h plus 6. And there we go. So hopefully you're starting to pick up on the pattern here. It's pretty easy. It requires some number sense to figure out what numbers multiply and add to these specific things. But if you can get that part down, then this type of factoring is pretty easy. Okay, I want you to try this one again, or try this one on your own again. So let's set it up. We're going to have a plus something times a plus something. We need two numbers that multiply to 24 and add to 10. Okay, and if you can do this in your head, if you don't need to write the x, that's fine. Okay, after you get really good at it, you don't need to write the x anymore. You can just think about it in your head. But I'm still going to write it out since you guys are just learning it. So let's write out all the ways that we can multiply to 24. We could do 3 and 8. We could do 4 and 6. So the only combination that adds to 10 is 4 and 6. So there we go. So hopefully you can see the pattern, you can see the structure. They all look very similar. Okay, that's why I'm setting it up with the variables and the blanks, and we're really just filling the blanks in here. All right, another one, I want you to pause and try it on your own. All right, so this one, I'm not going to make the x. I'm just going to try to do it in my head. So I'm going to set it up. And I know that I'm trying to find two numbers that multiply to 1 and add to 2. Well, there's only one way to multiply to get 1, and that would be 1 times 1. Conveniently, 1 plus 1 is 2, so there we go. Now, anytime I have two of the same factors like this, y plus 1 times y plus 1, we could write it like this, or we could condense it a little bit and write it as y plus 1 squared. Since it's something times itself, we can write it using the exponent like that. So let's take a look at what happens when we don't just have positive numbers. Okay? It starts getting a little more complicated. It doesn't change the initial setup. We're still doing this. We're still going to have two factors. Okay, but when we go to do our x, now we need to find two numbers that multiply to a negative 8 and add to a positive 2. Okay, well, that makes it a little more complicated when you have negatives and positives. If I'm multiplying to get a negative number, that means that the two numbers that I picked are different signs. Okay, one of them is a positive number, the other is a negative number, which complicates things. It makes it a little trickier to think about. So I want to do this. Let's start by thinking about just what multiplies to positive 8. I could do 1 times 8. I could do 2 times 4. All right? Now, one of the numbers in the pairs has to be a negative. So let's try this. What if I have negative 1 times 8, or negative 2 times 4? Or we could flip which one has the negative. We could make it a positive 1 and a negative 8, and positive 2 and a negative 4. And then we're trying to figure out which combination adds to a positive 2. Okay? Negative 2 and positive 4 are going to add to a positive 2. So now I get my numbers. Now, this one where I have x plus negative 2, we should change so that it's an x minus 2, because anytime we're adding a negative, that's the same as subtracting. And there we go. So anytime the signs are different, it makes it a little more complicated. So let's look at another one like that. We're still going to start the same way. G plus some number times G plus some number. Okay, but this time we're finding two numbers that multiply to a negative 10 and add to a positive 3. So again, let's start with numbers that multiply to positive 10. We can do 1 times 10. We can do 2 times 5. So let's duplicate this because we know that we have two cases. Either the 1 is negative or the 10 is negative. The 2 is negative or the 5 is negative. We need to find the combination that adds to positive 3, okay, which would be negative 2 and positive 5. So now we get G plus negative 2, G plus 5. And just like last time, we're going to change this G plus negative 2 to G minus 2. All right, just a few more here. All right, with this one, our C and our B value is negative, so we need to find two numbers that multiply to negative 3 and add to negative 2. So one of my numbers is still going to be negative, the other is going to be positive, because a positive times a negative is the only way that I can multiply and get a negative 3 here. Okay, so to get negative 3, it's either going to be negative 1 times 3 or positive 1 times negative 3. The one that adds to negative 2 is a positive 1 and a negative 3. So we get a plus 1, a plus negative. I'm going to rewrite. So we have a plus 1 times a minus 3. And there we go. All right, so just to kind of finish this off, I have two that I want you to try. So go ahead, pause the video, give it a shot, and then I'll run through the solutions quickly. All right, so for the first one, we need two numbers that multiply to a positive 2 and add to a negative 3. Okay, this one's a little tricky. Remember, like in the warm-up, if I have two numbers that multiply to a positive but add to a negative, that means both of my numbers have to be negative, because we know that two negatives, when multiplied, make a positive. So the only way that I could make a positive 2 with two negative numbers is if I do negative 1 times negative 2. Conveniently, they both add up to make a negative 3. Okay? And then we can just change this so that it's C minus 1 times C minus 2. Okay, for number 2, this one's a little easier since we have positive numbers. We just need to find two numbers that multiply to 5 and add to 6. Since they're both positive, it's a little easier to think about in our head. Okay, the only way that I can multiply to get 5 is 1 times 5, which also adds up to 6. So there we go. Okay, hope you found the video useful. Feel free to rewatch, rewind, pause. Please ask questions, and have a wonderful day.